Hey guys, today I'm going to be teaching you about organic chemistry, and we're going to be revising part 1 of organic chemistry. I'm going to be teaching you easy methods that actually work. So when it's your exam time, it will be very easy for you to answer exam style questions. And I'm going to be giving you some tricks and some easy methods so you can memorize and find this chapter easy, because a lot of people find it tough, but I will break it down and it's actually not that hard if we really look at it. Okay, so the first thing I want you to think about when I talk about organic chemistry is the name alkanes. Alkanes are compounds that are hydrocarbon compounds. So basically they contain hydrogen and carbon bonds only. That's what's a hydrocarbon. So like I said, when we talk about organic chemistry, the first thing that should come up to your mind is alkanes. And I'll tell you why. Because now we're going to be looking at the general formula of all alkanes. And I'm telling you, if you have this formula memorized, this whole chapter will be a cakewalk, okay? So the general formula for all alkanes is CnH2n plus 2. That is it. That's the general formula. That is all. That's the main part of the whole chapter. So if you have this memorized, easy peasy. Now I'm going to break it down what this formula actually means, okay? So N here after C is basically the number of carbon atoms present in this alkane. So the number of carbon atoms. And N here also means the same thing, the number of carbon atoms. So let's say we have C2. So the number of carbon atoms is 2, right? Then we have H, let's write it, H2. And N basically means 2 into N. Now we know that Cn is 2. So 2 into 2 plus 2, basically. So C2, H, 2 into 2 is 4, plus 2 is 6. So now we know the general formula, and through the general formula we can build different structures and different molecules. And this is basically all you need to remember, okay? Okay, so in IGCSE chemistry there is 6 alkanes that you need to remember, okay? 6 alkanes. And the only thing that you need to remember is in what order they come. And now I'm going to teach you how to memorize in what order the alkanes come in. So the first alkane out of 6, the first alkane we're going to be looking at is methane. Okay, that's the first alkane. And the reason why it's the first alkane is because of the M in the front of the word. M means mono. Mono means 1. So how you're going to remember is that methane comes first, is you're going to remember mono. You're going to remember this M. This M is the most important part of this word. Because of this M, you're going to remember that methane is always 1 because of the word M. Now, since we know that methane means 1 means that methane has 1 carbon atom because of methane, M means 1. So remember, there's only 1 carbon atom. And a very important thing to remember in organic chemistry is that there can only be 4 bonds present between atoms, between carbon and hydrogen atoms. Remember, there's only 4 bonds that can be present. So that means 1, 2, 3, 4. And now we know that alkanes are hydrocarbons, means that they only have hydrogen and carbon bonds. And now we know that methane only has 1 carbon bond. So all the rest of the bonds need to be hydrogen because methane means 1. So we already have 1 carbon bond. So we need to fill it up with 4 bonds. So just write hydrogen, 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 hydrogen. And now by drawing this structure, we can look at the formula. So now we know that there is only 1 carbon atom. And now we're going to count how many hydrogen. So 1, 2, 3, 4. CH4. That is the formula for methane, CH4. And that's all. That's the first step. Okay, so now we're going to be talking about the second alkane. So first we know is methane, second is ethane. Ethane. And don't worry, it might seem hard to coordinate which alkane comes first and which alkane comes second, but I'm going to break it down for you. So how we're going to know about ethane? So now we know methane is 1, and what comes second is ethane. So ethane will have 2 carbon bonds because it's the second alkane. So 2 carbon bonds. And now I've already told you that each molecule has to have 4 bonds. Okay, so now they already share 1 bond. So 1, so left is only 3. 4 minus 1 is 3. So 1, 2, 3. Here again, this molecule only has 1 bond, so 4 minus 1 is 3. So 1, 2, 3. So because it's ethane, we know that there's 2 carbon bonds, and we know that each carbon bond has 4 bonds. And now we know that it only has 2 carbon bonds, so that means all the rest are hydrogen bonds. So we write H, 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 H. Now we count 2 carbon bonds, and how many hydrogen? 1, 2, 3, 4, 5, 6. 6 hydrogen. Okay, now we're going to be talking about the third alkane. And the third alkane is propane. Propane. Now, because it's the third alkane, we know that it's going to have 3 carbon atoms. So methane was first, it has 1 carbon atom. Ethane was the second, so it has 2 carbon atoms. And propane is the third, so it has 3 carbon atoms. So we're going to draw 3 carbon atoms. Now, like I said, 1 carbon atom has 4 bonds. So 1, 2, 3, 4. Then this already has 2, the middle one. 1, 2. So 3, 4. This has 1. So 2, 3, 4. So we're basically going to fill it up with hydrogen because we know that propane only has 3 carbon bonds. So now we know that there's 3 carbon bonds surrounded with 1, 2, 3, 4, 5, 6, 7, 8 hydrogen bonds. Now, if we do not know the number of bonds, basically all we have to do is remember the general formula of alkane, which is CnH2n plus 2. So how many carbon bonds there are here? There's 3. So C3H. So 2 into 3. 2 into 3 is 6 plus 2, 8. So basically, we already know that this is propane. That's all. Next alkane is the fourth alkane. And the reason how you're going to remember it is the fourth alkane is because it is butane. Always associate the letter B with 4. Butane. Fourth. Butane is fourth. You know that methane is first because mono, M is mono. Mono means 1. So methane is first, ethane second, propane third, and butane is the fourth. Associate B with 4. Always associate B with 4. Butane. And since it is the fourth alkane, it's going to have 4 carbon bonds. 1, 2, 3, 4. And now we know that each carbon bond has 4 other bonds. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And now we know that we associate B with 4. We know that it's butane and it already has 4 carbon bonds. So we need to fill up everything else with hydrogen. So C4H10. That is the general formula for butane. Now we're going to be looking at the 5th hydrocarbon, which is pentane. Always remember that 5 is pentane. Pentagon, 5 sides. Pentagon, pentane. Always associate 5 with pentane. Pentane. So since it's the 5th alkane, we know that it's going to have 5, 1, 2, 3, 4, 5 carbon bonds, and we know that each bond has 4 other bonds. So C5H12, that is the fifth alkane. And now is the last alkane. The last alkane is hexane. 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 So we know hexagon has 6 sides. That's how we can remember hexane. Hexane means 6. Hexane is 6. So 6 means it has 6 carbon bonds. So 1, 2, 3, 4, 5, 6. Like I said, it needs to have 4 bonds. So 1, 2, 3, 4. That's 14. So we know that there's 14. And hexane means 6. So 6 carbon bonds. So that's the formula for the last alkane. So now we are basically done, and I hope that I showed you a pattern in how you can identify the different alkanes. So hopefully this helped. Okay, so now we're going to identify the chemical behavior of alkanes. And this is for all the alkanes out there. So basically what we need to know is that alkanes, because they are gaseous, they're gaseous because they consist of carbon and hydrogen bonds only, and both of those are gaseous at RTP, at room temperature and pressure. So we know that when these gaseous alkanes, for example methane, all of these alkanes, they burn in a good supply of air, and once they burn in air, basically once the alkane burns in oxygen, it will always form carbon dioxide plus water, and it's an exothermic reaction, therefore it releases energy. So this is a very important reaction in this chapter. Okay, so we know that methane, let's take example. The first alkane is methane plus oxygen. Oxygen basically in a good supply of air means with oxygen. So when methane burns in oxygen, in air, it forms carbon dioxide plus water. And since it's an exothermic reaction, it releases energy into the atmosphere. So now we know the structural formula of methane, because methane, M, means 1, mono. So we know that 1 means 1 carbon atom. So we're going to write 1 carbon atom. And we know that each carbon atom has 4 bonds. Therefore, we know that 1 carbon atom is bonded to 4 hydrogen atoms. And therefore, we know the general formula of methane. Now, we know oxygen is a diatomic molecule because it is a gas. So we know that oxygen is O2. Oxygen is just O, but since it's a gas, it's diatomic. That means it has 2 atoms of oxygen. So this forms carbon dioxide, CO2. It's CO2 because it is a gas. Again, we write all gases with 2, any gas. We write all gases with 2 because they're diatomic. Plus water, we know water is H2O, plus energy. But of course, this is a chemical equation, so we don't really need to show anything for energy. But when we write the word equation, it is always good to mention the energy. But once writing the chemical equation, there's no need. And now we will have to balance the equation. So once you count the oxygen, there's 2, 3 oxygen. And on this side, there's only 2. So we can put over here 2. So 2 into 2 is 4 oxygen on this side. And to balance it out, we can put 2 here. So 2 into 1 is 2, and here is just 2. So 2 plus 2 is 4. So here's 4 oxygen, and here's 4 oxygen. So now we have a balanced equation. Okay, now we're going to be talking about alkenes. So when we talk about organic chemistry, the first thing that should come up to your mind, like I said, is alkanes. Now the second thing that should come up in your mind is alkenes. Alkenes. Alkenes form another homologous series, and they're also hydrocarbon, meaning that they only contain carbon and hydrogen bonds. So now let's state the general formula for all alkenes. So it's almost similar to the first formula of the alkanes. So alkenes, meaning CN, H, 2N. That is it. In alkanes, there was CnH2n plus 2. But now that we're talking about the second, meaning the 2 has gone away, so this equation is a little bit smaller. So we remove the 2 because it has slipped away, because now we're talking about the second part of organic chemistry, and now the 2 has slipped away. That's basically how I remember this part of organic chemistry. So the 2 has slipped away because we're talking about the second part. Another important part of alkenes is that alkenes are unsaturated. So, unsaturated. What that means is that all alkenes have a double bond present between carbon atoms. Double bond. There's 2 bonds. So now we know that each carbon atom has 4 bonds. So now we know that it already has 2 bonds. So 4 minus 2 is 2. So we know that it only can have 2 more bonds. And same here, 1, 2, 3, 4. And we basically write it on the side instead of straight or anything. So 1, 2, 3, 4. 1, 2, 3, 4. So there's 4 bonds between each carbon atom in an alkene. And they're unsaturated hydrocarbons. Hydrocarbons. Because they contain hydrogen and carbon bonds only. Always remember the word only. So unsaturated hydrocarbon. So the reason why they're called unsaturated is because it is possible to break down one of the 2 bonds to add extra atoms to the molecule. But anyway, just remember that alkenes are unsaturated. That's all you need to know. And that they have a double bond between 2 carbon molecules, and that is it. And now there's only 3 alkenes that you should remember in the syllabus. Okay, so the first alkene we're going to be talking about is ethane. So always remember that ethane has 2 carbon atoms, and they each have a double bond between each other. Now because they already have 2 bonds here in between, so 3, 4. So 1, 2, 3, 4. And just fill them up with hydrogen, because we know that ethane only has 2 carbon atoms. So 2 carbon atoms, and they all have 4 bonds. Okay, so that's how we can say is that C2H 1, 2, 3, 4. So always remember, however many carbon atoms are present in alkenes, always the double amount is the hydrogen atoms. So if we have 4 carbon atoms, then we will have 8 hydrogen atoms. Always remember it is double. So whatever we have, like we have 1 carbon atom, that means we have 2 hydrogen atoms, and so on. There's always a double amount of hydrogen atoms. Now, the second alkene that we're going to be talking about is propane. Okay, now I know that this might look a little complicated, but always remember that this part of all alkenes will remain the same. This part, basically. This part. C double bond C, and always that. So always remember that. Then the third is butene. Now we know B means 4. Always remember, B is 4. So 1, 2, 3, and then a double bond between the 4th carbon atom, because we know that all alkenes have at least 1 double bond between 2 carbon atoms. So here we have it. And we know that each carbon atom has 4 bonds. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now we just fill it in. It's really simple, guys. Basically, all you need to remember is the formula, the general formula, which is CnH2n, just the double of whatever is happening, okay? So that's all. So now we might be wondering, how do we get alkenes? So basically where we get our alkenes from is from catalytic cracking. Very important. Catalytic cracking. The title itself, catalytic, means it involves a catalyst. Catalytic, catalyst. Catalysts speed up the rate of any reactions. So this is how we get catalytic cracking. Then another reaction that can take place is a thermal cracking. Using thermal energy to crack. So basically, all we need to do in these two reactions is take an alkene and use either heat in this case or a catalyst in this case to break it down to form an alkene molecule. So it goes from an alkane with either the help of a catalyst or alkane with the help of heat. There's two cases. The first is a catalyst and the second one is heat. So alkane with the help of a catalyst gives us an alkene. Same thing here. Alkane with the help of heat gives us an alkene. Always remember. And thermal cracking just happens at a higher temperature. At a higher temperature. Always remember that is what it is. At 500 degrees Celsius, and this can happen between 800 to 850 degrees Celsius. And catalytic cracking takes place with two oxides. It's a mixture of oxides of aluminium and chromium. Those are the catalysts used in this reaction. So these catalysts are heated to about 500 degrees for catalytic cracking to take place, And this happens, thermal cracking happens at 800 to 850 degrees. It happens at a higher temperature. And that's how we can get the alkenes. Another important reaction that takes place in this chapter are addition reactions. And there is a few addition reactions. Addition reactions means basically putting and creating larger molecules. So ethene molecule, we can add hydrogen to an ethene molecule to produce an ethane molecule. So ethene plus hydrogen gives us ethane. That is it. So ethene plus hydrogen gives us ethane. Always remember addition reactions. We're going from the second hydrocarbon to the first hydrocarbon, and to go from the second to the first, we are reversing, we are adding. So basically from an ethane to an ethene molecule, we are cracking, we are breaking it down to form smaller molecules. But when we are adding from ethane, we're adding something, we're adding hydrogen to form ethane. Basically, if we know the general formula of ethane, we can write the chemical reaction. That is all. Another addition reaction is, so this reaction is called hydrogenation because we are using hydrogen. That is it. Since we are using hydrogen, it's called hydrogenation. Hydrogenation. That is it. That's the first addition reaction that you should know about. Now we're going to be talking about the second addition reaction that you should know about, and it is called the hydration reaction. Hydration, it is also an addition reaction. Hydration means providing hydration. Hydration means water. Hydration, think of wet, hydration. To be hydrated means to drink water. And basically this reaction doesn't take place in the presence of water, but it takes place in the presence of steam because it is water in gaseous form. So basically this reaction is also an addition reaction. And like I said, it uses steam. So ethene plus steam give us ethanol. That's all. Now we know ethene is C2H4 double, and steam, we know that it's water, H2O, gives us ethanol. So this, please memorize this, C2H5 This will always come handy in organic chemistry. C2H5OH. That's the formula for ethanol. It's better to just memorize this by heart, and that's all. Then you can always form any reactions or anything. And all these hydrogenation reactions are very easy because we already know the general formula of all of this, like I already taught you in the beginning of the video. Okay, now we're going to be talking about a very important reaction. It's called halogenation. Halogenation. And it's very easy to remember why it's called halogenation. Look at the word halogen. Break it down. Halogen. Halogen means a gas that has a full shell of outer electrons, meaning 8 outer shell of electrons. Therefore, it's a halogen. And we know a few halogens. And basically, to remember what is halogenation is by thinking about bromine. Bromine is a gas. It is a halogen, and it is found in the 8th row of the periodic table. So halogenation means we can create a bromine water test to test for unsaturated solutions. Basically, what that means is that we know that the alkene has a double bond between carbon atoms. Therefore, it is unsaturated. It's an unsaturated hydrocarbon. It's unsaturated. So bromine, natural color of bromine is brown or orange, whatever you prefer. And basically, this bromine will become colorless in the presence of an unsaturated solution. We know that only alkenes can be unsaturated just because they have a double bond between 2 carbon atoms. So in alkene, bromine water turns colorless. It goes from brown to colorless. Always remember, brown to colorless in an alkene solution. That is all you need to remember. And now we're going to be looking at how to actually draw it. So we're going to be drawing it. First, we'll write the equation. So we're going to take ethene. We know only alkenes are unsaturated simply because they have a double bond between 2 carbon atoms. So ethene plus bromine. Bromine is a halogen. That's why it's called halogenation. Bromine give us dibromo ethane. That's all. Just remember this word, dibromo ethane. That's it. It's ethane because of ethene. If you use methane, then it's methane. That's all. That's all you have to remember. Now we know that the formula of this is C2 and double. So 2 double means 4, so H4 plus bromine. It's a diatomic molecule because it is a gas, so it's 2Br2. Gives us, just memorize this, C2H4 Br2. Now we're going to draw it. So ethene has 2 carbon bonds between the molecules. So 1, 2, 3, 4, and then 1, 2, 3, 4. There's 4 bonds between each carbon atoms. 1, 2, 3, 4 plus bromine, bonded with bromine because it's diatomic, 2 atoms in this molecule. Give us 2 carbon, then 4 hydrogen, 1, 2, 3, 4. Just by remembering this equation, we can draw it. So 2 carbon, 4 hydrogen, and 2 bromine. That's what happens in a bromine water test. That is it. That's all you need to remember. And now all we need to remember, the last thing we need to remember is that all alkenes can have addition reactions. So let's take ethene. Ethene is an alkene, so it goes from this. Just draw that ethene molecule. It goes from this This is how we draw it. It goes from here to this. So this is an addition reactions that all alkenes, like I said, all alkenes go through. And that is basically all you need to know in this chapter. The only other thing that you can go through by yourself is how to form structural isomers and substitutional reactions. That is all I did cover. Those two things, structural isomers and substitutional reactions. But everything else from this chapter I covered, and if you have any questions or anything, please leave them down in the comments below, and make sure to subscribe to my channel for more of my content. Thank you so much for watching. I really appreciate it. Please leave a like. Bye!